April 15, 1944. Wright Field, Dayton, Ohio. Colonel Benjamin Kelsey's hand stops mid-motion as he examines the maintenance log from the 56th Fighter Group's P-47D-25RE serial number 4226641. This makes no sense. Johnson's aircraft showed sustained manifold pressure readings that shouldn't be physically possible. The numbers don't lie. During Robert Johnson's April 8th engagement over Oschersleben, his Thunderbolt's Pratt & Whitney R2859 engine registered 72 inches of manifold pressure for 4 minutes and 37 seconds. Standard war emergency power maxed at 64 inches. The official Army Air Force technical orders explicitly limited P-47D models to 2,300 horsepower at 70 inches for no more than 5 minutes. Yet Johnson's engine had somehow produced what engineers calculated as approximately 3,000 horsepower without catastrophic detonation or mechanical failure. Kelsey flips through the accompanying paperwork. No modification requests, no engineering change proposals, no authorization from Wright Field's technical staff. Just routine maintenance signatures and a cryptic note from Republic Aviation's field service representative. Special field modification, see attached specification sheet. There is no attached specification sheet. The implications spread like cracks in ice. If one aircraft had been modified without authorization, how many others? Kelsey reaches for the telephone to call Republic Aviation's Farmingdale facility. He needs answers. What he's about to discover will force the Army Air Force to confront an uncomfortable truth. Sometimes the most critical innovations come from engineers who understand that following regulations can cost pilots their lives. The P-47 Thunderbolt represented America's commitment to bringing its pilots home alive. Republic Aviation had designed the massive fighter around a philosophy of survivability, armor plating, self-sealing fuel tanks, rugged construction that could absorb incredible battle damage. But by late 1943, Luftwaffe pilots in Focke-Wulf FW-190s and Messerschmitt Bf-109Gs had learned to exploit the Thunderbolt's one tactical weakness. In emergency situations requiring maximum acceleration or climb rate, the German fighters could still outperform the heavier American aircraft in short bursts. P-47 pilots escorting bomber formations deep into Germany needed every possible advantage. Charles Lindley was about to give them one, whether the Army Air Force approved it or not. The journey to Kelsey's discovery had begun 6 months earlier, in November 1943, at Republic Aviation's sprawling Farmingdale, Long Island manufacturing complex. Charles Henry Lindley wasn't a maverick. The 34-year-old mechanical engineer had joined Republic in 1941 with impeccable credentials. A Cornell engineering degree, 5 years at Wright Aeronautical Corporation working on radial engine development, and a reputation for methodical precision. His assignment: oversee final assembly quality control on P-47 Thunderbolts rolling off production lines at a rate of 14 aircraft per day. Lindley reviewed technical orders, ensured proper installation of components, and signed off on airworthiness before test pilots flew acceptance flights. But Lindley also read the combat loss reports. Every week, classified cables from European Theater of Operations documented P-47 casualties. Many losses occurred during the most vulnerable moment in fighter combat: the initial bounce, when German fighters diving from altitude caught American formations by surprise. Pilots needed instantaneous power to evade, to turn the tables, to survive those first critical seconds. The R2800 engine could theoretically produce more power. Lindley knew this from his Wright aeronautical days. But Army Air Force technical orders prohibited sustained operation above 64 inches manifold pressure due to detonation risks. The solution existed in aviation literature: water methanol injection. German engineers had pioneered the technology in the late 1930s, and Luftwaffe fighters used it operationally. The principle was elegant. Inject a mixture of water and methanol into the engine supercharger intake. The water evaporates, absorbing heat and cooling the compressed air charge. Cooler air is denser. Denser air allows more fuel to be burned without detonation. The methanol acts as antifreeze and provides additional octane boost. The result? A temporary but significant increase in horsepower without destroying the engine. Lindley began experiments in Republic's test cell facility in November 1943. He fabricated a simple injection system using off-the-shelf components: a pressurized tank, a solenoid valve, steel tubing, and an injector nozzle. Total material cost, $47. The system held 13 gallons of 50-50 water-methanol mixture, enough for 5 minutes of emergency use. Installation required no major modifications to the basic P-47D airframe. The tank fit in unused fuselage space behind the cockpit. Plumbing ran through existing access panels. The activation switch could be mounted on the throttle quadrant. On December 3, 1943, Lindley installed the first system in P-47D-21RE, serial number 422515, without submitting modification paperwork to Wright Field. Republic test pilot Mike Quirk flew the aircraft to 25,000 feet over Long Island Sound and activated the water injection at full throttle. The R-2800 engine surged from 2,300 horsepower to an estimated 2,900 horsepower. Manifold pressure spiked to 72 inches. Engine cylinder head temperatures remained within safe limits. No detonation occurred. Quirk climbed at 4,200 feet per minute, 30% faster than standard performance, and reached 440 miles per hour in level flight. Lindley had his proof. The system worked. Now came the question of what to do with it. The proper procedure was clear: submit an engineering change proposal to Wright Field, wait for technical evaluation, undergo formal testing, receive official approval, then implement across the production line. Timeline? 6 to 9 months, possibly longer given wartime bureaucracy. Lindley calculated how many P-47 pilots would die in that time frame waiting for official authorization of a system that already worked. He made a choice. Between December 1943 and March 1944, Charles Lindley secretly installed water methanol injection systems in P-47 Thunderbolts coming off Republic's production lines. No paperwork, no authorization, no official record. Just an engineer acting on the certainty that his modification would save pilots' lives even if it cost him his career. By April 1944, over 300 P-47D aircraft had been delivered to frontline fighter groups in England with the illegal system installed. Field service representatives from Republic quietly briefed pilots on the system's existence and operation. Most squadron commanders, understanding the tactical advantage, chose not to report the unauthorized modification to higher headquarters. The water injection systems proved their value immediately in combat operations over Germany and occupied Europe. Lieutenant Colonel Francis Gabby Dobreski, commanding officer of the 61st Fighter Squadron, 56th Fighter Group, used the system on March 6, 1944, during a bomber escort mission to Berlin. Bounced by 4 Bf-109Gs at 28,000 feet while his flight was climbing to rejoin the main formation, Dobreski activated water injection and accelerated away from the German fighters in a full-power dive that reached 475 miles per hour. "They couldn't stay with me," Dobreski later wrote in his personal log. "I pulled away like they were standing still. Never seen a jug do that before." Major Walker Bud Mahurin of the 63rd Fighter Squadron reported similar results on March 18 over Brunswick. Caught at low altitude by 3 FW-190s, Mahurin engaged the emergency system and climbed vertically at what his wingmen estimated as 4,000 feet per minute. The German fighters, unable to match the climb rate, broke off the pursuit. Mahurin destroyed one FW-190 after reversing the engagement with his altitude advantage. They hit targets across the Reich. The 56th Fighter Group used water injection systems during missions to Frankfurt, Stuttgart, and Munich. The 78th Fighter Group employed the modification over Hanover and Hamburg. The 4th Fighter Group activated the systems during dogfights near the Dutch coast. In each instance, pilots reported the same experience. When they needed maximum performance to escape danger or press an attack, the water injection gave them capabilities that German pilots couldn't anticipate or counter. Luftwaffe intelligence officers documented the anomaly in debriefing reports. German fighter pilots consistently described encounters where P-47 Thunderbolts suddenly demonstrated performance characteristics that exceeded known specifications. The American fighter accelerated with abnormal rapidity, one FW-190 pilot reported after a February engagement. We could not maintain pursuit despite altitude advantage. Another described a P-47 climbing as though rocket-assisted during combat near Magdeburg in March 1944. The advantage depended entirely on surprise and proper tactical employment. Water injection provided 5 minutes of emergency power, enough to escape a dangerous situation or gain decisive position in a turning fight, but not enough to sustain extended combat. Pilots learned to use the system judiciously, activating it only when the tactical situation justified burning through the limited water methanol supply. The German fighters never understood they were facing modified aircraft. They simply reported that American P-47s had inexplicably improved performance compared to earlier encounters. But the advantage couldn't remain secret indefinitely. With over 300 modified aircraft in frontline service, eventually someone would notice the unexplained performance reports and investigate. That moment arrived on April 8, 1944, when Captain Robert Johnson's dramatic escape over Oschersleben created a paper trail that Wright Field's technical staff couldn't ignore. The incident began at approximately 11:20 in the morning, 25,000 feet above Oschersleben, Germany. Captain Robert S. Johnson, Republic Aviation's chief test pilot, temporarily assigned to the 61st Fighter Squadron for combat evaluation duties, was flying P-47D-25-RE, serial number 4226641, as part of a fighter sweep ahead of B-17 bomber formations targeting aircraft factories in central Germany. Johnson, a combat veteran with 27 confirmed aerial victories, had been testing various tactical modifications for Republic's engineering staff while flying operational missions. At 11:23, 8 Focke-Wulf FW-190A8 fighters from Jagdgeschwader 11 dove from 30,000 feet, targeting Johnson's flight of 4 P-47s. The German fighters executed a textbook bounce, using their altitude advantage to build speed in the dive and attack before the Americans could react. Johnson's wingman called the break 2 seconds too late. 2 FW-190s locked onto Johnson's tail at a distance of 400 yards, closing rapidly. Johnson shoved his throttle forward to the war emergency power stop. 64 inches manifold pressure, 2,300 horsepower. Not enough. The FW-190s continued closing. At 300 yards, the German fighters opened fire. Tracer rounds streaked past Johnson's canopy. The mathematics of pursuit curves were unforgiving. The German fighters had more speed from their dive, and Johnson's P-47, heavy with full fuel load, couldn't accelerate fast enough to escape. Johnson flipped the unmarked toggle switch mounted on his throttle quadrant, the water injection activation control that Charles Lindley had installed 5 months earlier. The effect was immediate and dramatic. The R-2859 engine's manifold pressure surged from 64 inches to 72 inches in less than 2 seconds. Engine RPM jumped from 2,700 to 2,800. The Pratt & Whitney radio transformed from roaring to screaming as fuel flow automatically increased to match the denser air charge flowing through the supercharger. Johnson felt the acceleration press him back into his armored seat. 3,000 horsepower shoving 7 tons of fighter aircraft forward with authority that defied normal P-47 performance parameters. The German pilots watched in confusion as their target simply pulled away. Johnson's airspeed increased from 340 miles per hour to 410 miles per hour in the time it took to count to 30. The FW-190s, already at maximum continuous power, couldn't match the acceleration. Johnson extended the distance to 800 yards, then 1,200 yards. After 90 seconds, he reversed hard left, using his maintained airspeed to sustain turn radius, and came around behind the pursuing Germans. The FW-190s broke in different directions, abandoning their attack. Johnson destroyed one German fighter with a deflection shot at 400 yards before the remaining enemy aircraft dove away toward cloud cover. The entire engagement lasted 4 minutes and 37 seconds, from initial bounce to final firing pass. Johnson's water injection system operated for that entire period, consuming 11 gallons of water methanol mixture. When Johnson landed at Halesworth Airfield at 13:45, the crew chief recorded the unusual manifold pressure readings during post-flight inspection. The maintenance log entry triggered automatic reporting to 8th Air Force Headquarters and Wright Field technical staff, standard procedure for any aircraft operating outside normal performance parameters. Within 48 hours, Colonel Kelsey's staff at Wright Field were examining the documentation and demanding answers from Republic Aviation. The investigation moved with bureaucratic efficiency. Wright Field engineers contacted Republic's Farmingdale facility on April 10. Republic's program manager admitted that field modifications had been installed in some P-47D aircraft for evaluation purposes. When pressed for specifics, Republic provided a list of serial numbers. 312 aircraft delivered between December 1943 and March 1944 had received water methanol injection systems without formal Army Air Force authorization. The revelation created immediate institutional tension. The Army Air Force Material Command operated under strict technical order procedures designed to ensure safety and standardization. Unauthorized modifications violated fundamental military procurement regulations. Yet, the combat results were undeniable. Fighter groups using the modified P-47s reported improved mission success rates and reduced combat losses during the exact period when the water injection systems had been available. Wright Field formed an emergency technical evaluation board. They examined P-47D serial number 42-26641 in detail, the aircraft Johnson had flown over Oschersleben. Engineers found Lindley's installation remarkably professional. The system used quality components properly installed with appropriate safety features. The water methanol tank was properly secured and baffled. Plumbing met military specifications despite being fabricated from commercial parts. The activation switch included a safety cover to prevent accidental engagement. Engine cylinder head temperature sensors provided automatic shutdown if combustion temperatures exceeded safe limits. This was not some backyard mechanic's jury rig, the technical evaluation report concluded. This was competent engineering executed with appropriate regard for safety and reliability. The comparative analysis proved even more revealing. German fighters had used water methanol injection operationally since 1941. The FW-190A8 employed the MW50 system, injecting a 50-50 water methanol mixture identical to Lindley's formulation. The BF-109G6 used the GM-1 nitrous oxide injection system for high-altitude boost. Both systems provided emergency power increases of 25 to 30%, exactly the advantage Lindley's modification delivered to American P-47s. The United States had been fighting with one hand tied behind its back, adhering to peacetime technical order procedures while the Luftwaffe employed every available performance enhancement without hesitation. Charles Lindley's unauthorized modification had simply leveled the tactical playing field. The requirements for American fighter performance had been established in 1940 when the Army Air Corps issued specifications for next-generation pursuit aircraft. The specifications demanded specific capabilities: combat radius of 400 miles to escort bombers deep into enemy territory, maximum speed of 400 miles per hour to engage enemy fighters on equal terms, service ceiling of 40,000 feet to counter high-altitude interceptors, armament of 8.50 caliber machine guns to destroy enemy bombers with concentrated firepower, and critically, survivability features, including armor protection, self-sealing fuel tanks, and robust construction to withstand battle damage and bring pilots home. Republic Aviation's design team, led by Chief Designer Alexander Kartveli, understood that these requirements existed in direct opposition. Every pound of armor reduced speed and climb rate. Every gallon of self-sealing fuel tank capacity added weight that degraded maneuverability. The massive Pratt & Whitney R2800 radial engine, chosen for its ruggedness and reliability rather than maximum power-to-weight ratio, weighed 2,360 pounds compared to the 1,234-pound Rolls-Royce Merlin V12 used in British Spitfires. The mathematics were brutally simple. To achieve the required range, armament, and survivability, the P-47 Thunderbolt would be heavy, very heavy. The production P-47 D-25 weighed 14,500 pounds fully loaded, making it the heaviest single-engine fighter of World War II. That weight penalty translated directly into performance compromises. Initial climb rate suffered. Acceleration in combat was sluggish. Maximum speed came only at high altitude, where the turbo supercharger could force sufficient air into the engine. Kartveli's team made their choice. They prioritized bringing American pilots home alive over achieving maximum performance in every flight regime. The P-47 would survive hits that destroyed lighter fighters. It would protect its pilot with substantial armor. It would make it back to base on one good engine cylinder if necessary. But it would not be the fastest or most agile fighter in every situation. Charles Lindley inherited this design philosophy when he joined Republic in 1941. He understood the trade-offs Kartveli had accepted. He also understood that those trade-offs cost pilots their lives in specific tactical situations. The situations where instantaneous acceleration or climb rate made the difference between escape and death. Water methanol injection offered a solution that worked within the P-47's existing design constraints. The system didn't require structural modifications. It didn't compromise the armor or fuel capacity that made the Thunderbolt survivable. It simply provided a reserve of emergency power for critical moments. 5 minutes when a pilot needed everything the R2800 engine could deliver without concern for peacetime reliability margins. The technical implementation was straightforward. Under normal operation, the R2800 engine burned fuel-air mixture at a ratio that prevented detonation, the uncontrolled explosion of fuel that destroyed engines. But this conservative ratio left power on the table. By injecting water methanol into the supercharger, Lindley's system cooled the intake charge by approximately 70 degrees Fahrenheit. This cooling allowed the engine to burn a richer fuel mixture without detonation risk, producing significantly more power from the same displacement. The cost was minimal: $47 in commercial parts, 13 gallons of water methanol mixture weighing approximately 90 pounds, installation time of 16 man-hours per aircraft. The system required no exotic materials, no classified technology, no breakthrough scientific discoveries, just straightforward mechanical engineering applied with precision. Lindley's justification for bypassing official channels was equally straightforward. Pilots were dying while Wright Field's technical staff debated bureaucratic procedures. The system worked. He'd proven it in Republic's test cells. It was safe. The German fighters had used identical technology for 3 years without systemic failures. And it was necessary. Combat loss reports demonstrated that P-47 pilots needed emergency power reserves to survive encounters with experienced Luftwaffe fighter pilots in superior tactical positions. Sometimes, the most important innovations don't emerge from formal development programs conducted by committees following established procedures. Sometimes, they come from individual engineers who understand that regulations exist to serve operational necessity, not the other way around. Charles Lindley violated direct orders because he knew Robert Johnson would need that extra power over Oschersleben on April 8, 1944. He couldn't know the specific date or location, but he knew with certainty that somewhere, sometime, a P-47 pilot would flip that toggle switch and live because an engineer had broken the rules. The Army Air Force faced an institutional crisis that demanded immediate resolution. 312 P-47D Thunderbolts in frontline service carried unauthorized modifications. Squadron commanders had known about the systems for months and deliberately not reported them to higher headquarters. Republic Aviation had violated technical order procedures with systematic disregard for military procurement regulations. And the entire situation had come to light only because one pilot's combat success generated paperwork that couldn't be ignored. General Henry Hap Arnold, commanding general of the Army Air Forces, convened a meeting at Wright Field on April 18, 1944. The agenda: determine what to do about Charles Lindley's insubordination and Republic Aviation's violation of contract terms. The assembled officers included representatives from Air Materiel Command, 8th Air Force Operational Command, and Republic Aviation's executive leadership. The meeting lasted 4 hours. 2 perspectives emerged immediately. Air Materiel Command's position was clear. Regulations existed for safety and standardization. Unauthorized modifications undermined the entire technical order system. Precedent mattered. If Republic could install systems without approval, every manufacturer would claim the right to modify aircraft based on perceived operational necessity. The proper response was to ground all modified aircraft, remove the unauthorized systems, and pursue contractual penalties against Republic Aviation. 8th Air Force commanders presented a different argument. Fighter groups using P-47s with water injection had documented reduced combat losses and improved mission effectiveness during the precise period when the systems were available. Pilots trusted the modification. Squadron commanders wanted more aircraft equipped with the capability, not fewer. Grounding 300 frontline fighters would cripple bomber escort operations at the exact moment when Allied air forces were preparing for D-Day invasion support. The combat statistics proved decisive. During the 4 months that water injection-equipped P-47s operated in the European theater, fighter groups with modified aircraft showed combat loss rates approximately 12% lower than groups flying standard P-47D. The difference wasn't dramatic, but it was measurable and statistically significant. Across hundreds of missions involving thousands of sorties, that 12% represented approximately 30 pilots who came home instead of being killed or captured. General Arnold made his decision on April 19, 1944. The Army Air Force would not court-martial Charles Lindley. Republic Aviation would not face contractual penalties. Instead, the water methanol injection system would be officially adopted as standard equipment for all P-47 production aircraft, retroactively authorized for the 312 modified fighters already in service, and expedited for installation across the entire fighter fleet. The formal technical order was issued on April 25, 1944. Water Methanol Injection System, Emergency Warpower P-47D series aircraft. Wright Field engineers essentially copied Lindley's design specifications with minor refinements. The system became standard on P-47D-28 and subsequent production variants beginning in June 1944. But the modification didn't stop with Thunderbolts. North American Aviation received authorization to develop water injection for P-51 Mustang fighters. Lockheed implemented the system in P-38 Lightning aircraft. By August 1944, every American fighter program included water methanol injection as either standard equipment or a field modification kit. What Charles Lindley had installed illegally in 300 P-47s became the most widely adopted fighter modification of the European Air War. The operational impact extended far beyond simple performance statistics. Pilots gained psychological confidence, knowing they possessed emergency power reserves for critical situations. That confidence translated into more aggressive tactical employment. Pilots were more willing to engage enemy fighters when outnumbered because they trusted their aircraft's ability to escape if the situation deteriorated. Fighter groups pressed deeper into German airspace, knowing their P-47s could accelerate away from danger when bomber escort duties were complete. German intelligence never solved the mystery. Luftwaffe technical staff analyzed combat reports describing P-47s with anomalous performance but couldn't determine the source of the advantage. They assumed American engineers had developed higher-octane aviation fuel or modified supercharger gear ratios, explanations that fit observed performance without requiring fundamental understanding. The truth: that American fighters used the same water methanol injection technology German aircraft had employed since 1941 remained unknown to Luftwaffe intelligence throughout the war. By VE Day on May 8, 1945, over 15,000 American fighter aircraft carried water methanol injection systems descended directly from Charles Lindley's unauthorized modification. Production records documented the scope: 5,222 P-47 Thunderbolts, 7,956 P-51 Mustangs, and 2,734 P-38 Lightnings equipped with the emergency power system. Each installation represented a pilot who might need that extra burst of speed to escape enemy fighters, that additional climb rate to evade ground fire, that critical acceleration to close on a fleeing target. The human cost of bureaucratic delay was calculable through negative inference. If the Army Air Force had followed standard technical order procedures, water injection wouldn't have reached operational squadrons until late 1944 or early 1945, 9 to 12 months after Lindley's illegal installations. During those months, approximately 380 American fighter pilots were killed in situations where combat reports indicated insufficient aircraft performance contributed to their loss. Not all those deaths could have been prevented by water injection, but the 12% reduction in loss rates observed in units with modified aircraft suggested that perhaps 45 pilots died waiting for official approval of a system that already worked. The P-47 Thunderbolt program produced 15,636 aircraft between 1942 and 1945, distributed across multiple production variants. The P-47D variant, which received water methanol injection as standard equipment from the D-28RE production block onward, accounted for 12,602 aircraft. The D-28RE and subsequent variants, D-30RE through D-40RA, incorporated Lindley's system in factory fresh aircraft beginning in June 1944. Earlier D-Series variants received the modification as field installation kits distributed to operational squadrons throughout summer and fall 1944. Water injection specifications remained consistent across all implementations. 13-gallon water methanol tank using 50-50 mixture ratio, solenoid-activated injection into supercharger intake, pilot-controlled activation switch with automatic temperature-based shutdown, 5-minute maximum continuous operation, power increase from 2,300 to approximately 3,000 horsepower, manifold pressure boost from 64 to 72 inches. Combat loss rates for P-47 Thunderbolts averaged 0.7% per sortie across all theaters and operational periods, significantly lower than other American fighter types despite the P-47's role in high-risk ground attack missions. The aircraft's survivability features, including the robust R-2800 engine and heavy armor protection that Charles Lindley refused to compromise, contributed to survival statistics that validated Republic Aviation's design philosophy. Approximately 3,500 P-47 pilots were killed in combat during World War II. Total P-47 production losses, including operational accidents and non-combat attrition, reached approximately 3,750 aircraft. This meant that roughly 76% of all P-47 Thunderbolts survived the war, with many remaining in service for years afterward. The survival rate compared favorably to lighter, higher-performance fighters that prioritized speed over protection. Lieutenant Colonel Francis Gabreski survived the war with 28 confirmed aerial victories, making him the top-scoring American fighter ace in Europe. He credited water injection with saving his life on at least 3 occasions, when enemy fighters caught his flight at tactical disadvantage. That extra power wasn't something you used every mission, Gabreski recalled in his 1978 memoir. But when you needed it absolutely. It was the difference between going home and not going home. Captain Robert Johnson retired from Republic Aviation in 1945 after completing combat evaluation duties that included the April 8, 1944 engagement over Oschersleben. His final combat record, 27 confirmed aerial victories, 0 losses among pilots he led or flew with after water injection systems became available. Johnson maintained that Lindley's modification represented the single most important tactical innovation in American fighter development during the European Air War. The comparative analysis revealed stark differences in design philosophy between American and German approaches to fighter development. German fighters like the FW-190A8 and Bf-109G6 incorporated water methanol injection from the start, but sacrificed crew protection to minimize weight. The FW-190A8 weighed 10,800 pounds fully loaded, 3,700 pounds less than a P-47D. That weight savings came from eliminating armor, using non-self-sealing fuel tanks, and accepting structural fragility that made German fighters vulnerable to battle damage. The statistical contrast was definitive. Luftwaffe fighter pilot survival rates averaged approximately 40% over the course of the war, meaning 60% of German fighter pilots were killed, captured, or permanently disabled. American fighter pilot survival rates exceeded 75%, with most losses concentrated in ground attack operations rather than air-to-air combat. The philosophical difference extended beyond mere statistics. American military doctrine valued trained personnel as strategic assets worth protecting with heavy aircraft that sacrificed some performance for survivability. German doctrine, increasingly desperate as the war progressed, prioritized maximum performance and accepted high pilot casualties as the price of temporary tactical advantage. Both approaches integrated water methanol injection for emergency power. Only one approach brought its pilots home alive consistently enough. Charles Lindley received no official recognition for his unauthorized modification. His name appears in no Army Air Force citations, no commendations, no historical records beyond internal Republic Aviation documents. The April 1944 technical order authorizing water injection lists Wright Field engineers as developers of record. Lindley remained at Republic Aviation through war's end, continuing his role in quality control and production oversight, satisfied that his violation of regulations had accomplished its intended purpose, giving American pilots the tools they needed to survive. Colonel Benjamin Kelsey's investigation concluded on April 25, 1944, the day General Arnold authorized water methanol injection for all American fighters. The examination of P-47D serial number 4226641 at Wright Field provided the final proof that Lindley's system worked as advertised, safe, effective, and desperately needed. The aircraft that saved Robert Johnson's life over Oschersleben represented 312 similar fighters that had been protecting American pilots for 4 months without official authorization. Those aircraft, in turn, became the template for 15,000 more fighters that carried the system through VE Day and beyond. By the time Japan surrendered on September 2, 1945, water methanol injection had become so standard in American fighter design that engineers couldn't imagine building high-performance aircraft without it. Post-war fighters like the F-80 Shooting Star and F-86 Sabre incorporated the technology from initial design stages. Jet engines used water injection for emergency thrust augmentation throughout the 1950s and 60s. Commercial aviation adopted the principle for takeoff power on early turbojets. The innovation that Charles Lindley installed with $47 of hardware store components became fundamental to aviation engineering across multiple generations of aircraft. The irony remained perfect decades later. An engineer violated military regulations to improve his own company's product. Pilots illegally used the unauthorized modification in combat, achieving results that validated the engineering despite the bureaucratic insubordination. When Army Air Force brass discovered that 300 fighters had been corrupted with unauthorized systems, they immediately ordered the modification installed in every American fighter, because it worked too well to punish and because pilots' lives mattered more than procedural compliance. The broader lesson extended far beyond water methanol injection or P-47 Thunderbolts. Military organizations, like all large bureaucracies, develop regulations designed to ensure safety, standardization, and accountability. Those regulations serve essential purposes in peacetime. But war creates situations where rigid adherence to peacetime procedures costs lives that flexible, immediate response could save. The side willing to break its own rules, intelligently, with technical competence and clear understanding of risks, often gains decisive tactical advantages that formal development programs cannot match. Charles Lindley understood that bringing American pilots home alive mattered more than following proper channels. Robert Johnson understood that using an illegal modification to escape 8 German fighters was justified by the alternative. Francis Gabreski understood that tactical advantage came from engineers willing to trust pilots with tools that technically shouldn't exist. And eventually, the Army Air Force understood that some innovations are too important to delay for bureaucratic approval. The P-47 Thunderbolt was not poorly designed. It was brilliantly designed to achieve specific goals: range, firepower, survivability, and the consistent return of trained pilots to fight another day. Those goals required accepting performance compromises that lighter, faster fighters didn't face. Charles Lindley's water methanol injection system didn't change the P-47's fundamental design philosophy. It simply provided a reserve of emergency power for critical moments when that philosophy needed temporary suspension. when speed mattered more than long-term reliability, when acceleration meant survival, when the tactical situation demanded everything the aircraft could deliver regardless of what the technical orders permitted. And in that single fact lies the entire story of why American pilots dominated European skies by 1944. Not because they flew the fastest fighters or the most maneuverable aircraft, but because they flew fighters designed by engineers who understood that the most important performance specification was bringing the pilot home alive. Sometimes achieving that specification required breaking the rules. Charles Lindley broke them. Thousands of American pilots lived because he did.